Sadly, game theory isn't about old people theorizing what color the horse should be for World of Warcraft's next microtransaction, which I kinda wish it was, but rather it's about turning strategic interactions into mathematical models. One such interaction that is very important for both the hardest workers and the laziest consumers happens in food delivery apps. Most of these apps have a surge pricing model, where if there's a sudden large demand for drivers, their costs will balloon up, resulting in larger earnings for the drivers. So naturally, some drivers start to cooperate, collectively turning off their availability to create an artificial scarcity and turning it back on once the high prices are reached. I think this is actually kinda cool, so naturally I want to recreate this behavior using AI in Unity. For the sake of this experiment, I will generalize food delivery into just service providing. So, for the first iteration of this experiment, there will be a service provider, such as Bob here, and he will earn a coin after providing his service. But he can also potentially earn more coins by providing service in a high-cost area. Here, Bob and his friends start interacting with the environment with the goal of earning as many coins as they can in 10 seconds. Right off the bat, they were just spam jumping off the platform to end their misery, which is probably the fastest time any AI model has ever trained to accurately respond to how shitty these apps are to their drivers. In order to make these agents literally calm down, I changed it so that they couldn't move while providing service. But the only thing that changed was that they realized maybe life is better on the edge. After spending way too much time on this, I realized it was a simple movement bug, where the agents were forced to move to the bottom left corner and nowhere else. So, after fixing that issue, their movement looked a lot better in the beginning. With perfectly working legs, the first way they abused the system was hovering near the corner of 4 different areas. Why, you might ask? Because in order to incentivize the agents to explore and enter high-cost areas, I decided to give them a tiny reward every time they entered one. But of course, spam entering and exiting potentially 4 different high-cost areas at once can rack up a score larger than any other method. So after fixing that, the newest strategy became just a spam providing service. So I made the bonus reward in the high-cost areas significantly higher, which actually didn't look terrible afterwards. And after some more minor tweaking, the results were looking pretty good. One cool thing about the Unity machine learning package is that you can train multiple different behaviors at once. To test this concept, I made this simple scene where the green agents were training to avoid the spinner, while the yellow agents were training to enter the yellow areas, and as you can see, it worked out pretty well. This means that we can build on top of the first experiment and introduce customers as a secondary type of agent. Unlike the service providers, these agents will prefer lower cost areas. And in order to be able to tell apart the different kinds of agents, the customers will have, let's see, how about cowboy hats? Since we have consumers now, high-cost areas won't just randomly spawn, but instead the consumers consuming will cause the costs to go up. And they will be aware of these high-cost areas, including their cost tiers and the positions relative to them. To start off, I only trained consumers, where their only task was to spread out to avoid high costs. But weirdly, they were just stacking on top of each other. But after lots of fixes, they were acting like you would expect, spacing themselves out. So now, it is time to bring in the service providers into the mix. They will earn money depending on how high the cost tier was at the location when they provided service. Furthermore, their act of providing service will bring down the cost in that area. After some training, one behavior I noticed was that the service providers were ganging up to drive up the costs faster, which is great. And perhaps the most interesting moment was when a few service providers and the customers were in this weird symbiotic relationship, but I'm not sure which side was winning here. At this point, in order to better understand the progress, I started collecting data from each agent, plotting the massive CSV files using Python. You can see that in this generation, the service providers were slowly but surely improving their earnings. But then I realized the data calculation was wrong. This was the total tiers accumulating since the beginning, which is also apparent since the graph is so smooth. Once I fixed that issue, the true domination of the service providers became even more apparent. In order to help the customers out a bit, now providing a service brought the cost in the surrounding areas all the way down to 0, as opposed to just decreasing it by 1 tier, which somewhat helped. The service providers got really good at laser focusing down the high cost areas and making use of them. In order to make the cost transitions more smoother, I also increased the number of cost tiers from 3 to 10. In the first generation, the agents barely ever reached the really high cost tiers. The way I understand the situation is, because all the service providers running around providing service, it was almost impossible to wait until a certain area reached the highest cost tier, so they probably never even knew this was possible. After a bunch of tweaking of the system, I believe I was able to get a pretty healthy distribution of cost areas. The service providers were trying to get the highest earnings, while simultaneously the customers were trying to get the best deals. As the final iteration of this experiment, I wanted to remove the high cost areas altogether. The service providers and the agents should just interact directly, without having this middleman that creates opportunities for the agents to just abuse. So, in the next generation, the customers will get hungrier over time, willing to pay higher and higher costs, and when they reach an agreement with the service providers, both parties will receive a score based on the cost tier. At first, everyone was just giving a big group hug, followed by just spam trading. I wanted to give the agents some more space, and in order to stop them from flocking together so fast, I tried to make the map twice as big, but instead I ended up creating this abomination somehow. When that didn't work, I started to reward customers for being further away from each other, and that did help a bit. And just for fun, here's a visual of all the agents using raycasts to detect every other surrounding agent around them. After more generations of tweaking and training, I finally reached a point where you can clearly see that the agents were waiting around like a hunter and pouncing as soon as the customers reached the highest cost tiers, which I would say in its essence was the target behavior that we were looking for, where the service providers are purposefully waiting to provide their service even though they can for the bigger and better reward. This project took dozens of hours of training and recording, which I skipped over in order to not make this video 2 hours long, but I think the end result wasn't half bad. What other complex interaction should I try to recreate by training AI agents within a system? Thanks for watching. Hope to see you next time.